Hello everybody, welcome to Sane Game Studios. I'm Sane, I'm an amateur game developer. Today on GameMaker Tutorials, we're going to be looking at improved platformer movement. So I'm talking about improved platformer movement. Essentially all I'm going to be doing is I'm going to be taking the code from my original platformer movement video and I'm going to be improving upon it in a couple ways. So we are going to be improving upon it in 3 ways today. The first way is we're going to be implementing something called Coyote Time. If you don't know what Coyote Time, it is a very old platformer concept, something that goes back to like the NES days, where if you are running towards the edge of a platform and you are trying to jump at the edge of that platform to clear a gap or jump to another platform, Coyote Time gives you a brief window where you are off the platform but still able to jump. And this allows for the player to have a little bit of, human error factored into what would otherwise be pixel perfect jumping. It's like if you were standing on the very edge of a platform and you jump, you can jump. Because we currently in the code, we have it set to if you are grounded, you can jump. If you're standing on the ground, you are grounded. But if you are running towards the edge of a platform, if you move 1 frame too far, so you are like a pixel off of the platform, you can no longer jump. But in the eyes of the player, they're going to think that they jumped to the perfect moment, but the game actually didn't jump. But what truly happened is that they didn't jump at the perfect moment. They jumped just a frame too late. And that's not really fair on the player. We want to give them a little bit of leniency. So to do that, we're going to introduce Coyote Time, where if you're running towards the edge of the platform and you run off of the platform, there is still a couple frames or a small brief window in which you are able to jump still. So it gives the player the illusion of pixel perfect jumping, when reality is there is a bit of a leeway to allow for human error on the side of the player. The next thing we're going to be looking at is acceleration, so that when you hit the arrow key to move in one direction or the other, instead of going from a complete dead stop to full movement speed, there will be a period where you are speeding up to movement speed. But also in reverse, when you let go of the arrow key, you don't come to an immediate stop, you gradually slow down. And visually, like in the game, visually, it's not going to make much of a difference. But in terms of how your game feels, it's going to make a big difference. So I will show you how to code it, and there are multiple ways to code it. I'm going to be showing you how to do it without a function that does calculation for you. I'm just going to be doing it in the step event. But when I go to actually show you guys what it's done, it's going to be very hard to actually perceive it. But if you code it yourself and you go and you play the game, you will feel the difference. And the difference does feel like quite a bit. Then the final thing we're going to be doing is we're going to be cleaning up our collisions. So our biggest issue right now, if you did follow my previous tutorial, is that if you are falling towards the ground and your vertical speed is, let's say, 10, and we are detecting to see if there is a collision at our Y position plus our vertical speed. But then every frame, we are also adding gravity to our vertical speed, which is 0.3. So if your vertical speed is 10 and you are moving down 10 pixels per frame, if in this current frame you are 10 pixels away from the ground, it is going to stop your vertical movement, it is going to set grounded to true, and it is going to change your sprite to be the idle sprite or the walking sprite. But during the next frame, your VSP is going to become 0.3 and you will be 10 pixels away from the ground, so it will change back to the falling sprite and continue falling. And it creates a brief halt and sprite swap while you are still in the air and currently falling, and then it continues falling at a lesser speed. And it looks glitchy, it looks janky, it doesn't look great. So we're going to be improving upon that so that you constantly move towards the ground without changing your sprite, and then eventually collide with the ground and seamlessly transition into the walking or idle sprite. But the first thing I'm going to be doing is, because what I have here is I've actually watched my platformer movement video, and it was my first tutorial I ever did, and looking back on it, I can tell that it was the first tutorial I ever did. And I'm going to be cleaning up the code a little bit to be just nicer looking and easier to read. So I'm going to pull the code up, and here it all is. And I'm just going to be editing a few things. So here, instead of doing x equals x plus HSP, I'm just going to go x plus equals HSP. I'm going to cut that line and I'm going to move it here. I'm going to do the same thing to y equals y plus VSP. I'm going to get rid of that and just say if not grounded, VSP plus equals grav. Instead of going VSP equals VSP plus jump height, I'm going to go to VSP minus equals jump height. And then I'm going to go to the create event, and instead of making jump height -7, I'm just going to make it 7. And then I'm going to grab my collision here. I'm going to go down here. I'm going to create a new section. I'm going to call it collisions. I'm going to paste that code there. Right here, I'm going to say commit movement. Down here, I'm going to go animate. And honestly, I'm just going to rewrite this code. I think that sounds easier to me than just copying and pasting it. So I'm going to say if sign HSP does not equal 0, image x scale equals sign HSP. And I'm going to say if grounded, so if we are on the ground, if HSP equals 0, sprite index equals s player idle, else sprite index equals s player walk. And then if we are not grounded, so else if VSP is less than 0, so we are moving upwards on the y-axis, sprite index equals s player jump, else, so VSP is 0 or greater, sprite index equals s player fall. Get rid of any weird spacing. And that just looks cleaner, looks better. I am just much happier with that. But if I run it, it's going to work exactly the same. But to make it so that we can see the player a little bit better for what we're going to be doing in this tutorial, I'm going to be changing the background color of the room and adding a camera. If you don't know how to add a camera, you can go ahead and watch my camera movement tutorial where I show you how to create a camera object and how to have that camera object move around and be controlled within the game world. You can either look that up on my channel, or I'll actually throw a link to it in the description down below. So my viewport width, I'm going to set that to 640. by 360. And I'm going to set this to 1280 by 720. And that's just going to zoom in on the player and make it look better. Well, it'll zoom in on the room. We're going to create a camera object that will control the camera and make it follow the player. I'm not really going to explain what I'm doing here. If you want to learn more about how to do camera controls, you can go ahead and watch that tutorial. Like I said, link to it will be in the description. Then I'm also going to set the background color to be a gray, because I just find it easier to view, easier to see everything, sorry. So now if we run this, we're able to see everything much clearer. And if you can see it in the video, you'll see what I'm talking about when I'm talking about the vertical collisions, how there is a single frame where it almost looks like it's glitching out on the sprite. When it's not glitching out, it just does that because of the way that we have it coded. But the first thing we're going to do is we're going to look at Coyote Time. So to do that, we're actually going to first place a new instance of OWall in the room. And then I'm also going to change my jump height so that we can actually reach that. Let's just make sure we can reach it. Easy. So if we are standing right here, we are able to jump. But if we move one frame over, we are not. And the reason why that's an issue is if you are walking and you're trying to jump on the last frame, as you can see, I'm not even really able to do it. Oh, okay, that time I did it. But it's very, very difficult. So we're going to create a bit of a buffer window that allows the player to continue jumping even if they have missed the jump opportunity by a single frame. And to do that is rather simple. I'm going to go to my OPlayer create event and I'm going to create a new variable and I'm going to call it Coyote Time. And here, where it says grounded equals true, I'm going to set Coyote Time to equal 10. But if we are not on the ground, so grounded equals false, I want Coyote Time to equal itself minus 1. But to do that, we're going to do it in a bit of a cleaner way. So we could go Coyote Time minus equals 1, and that will absolutely do what it is that I wanted to do. But an even simpler way is I'm just going to go Coyote Time minus minus. And that's just going to minus 1 off of Coyote Time every frame that we are not on the ground. So then here where we are setting our jump height and adding it to our vertical speed, instead of being like key up and grounded, I'm going to say if key up and Coyote Time greater than 0. And what that's going to do is, since we are not on the ground, while we are not on the ground, we're going to be minusing 1 off of Coyote Time. And then while we're on the ground, we're going to be setting Coyote Time to 10. So when we leave the ground, every frame that we are off the ground, Coyote Time is going to have 1 minus off of it. And so every frame will go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. As long as it is above 0, we can still jump, which means that there is a 10 frame window after we leave the platform in which we are able to jump. And I will show you exactly how that affects the gameplay. So here we are. And if I were to try to jump on the last frame, I'm going to be able to do it every single time. And that is because if I am a little bit late, there is a leeway there that allows me to still jump. And if you see there, I blatantly walked off the edge and then jumped. So you can set this value to be higher or lower, and it will either increase or decrease the window for jumping, respectively. So with Coyote Time out of the way, we are going to implement acceleration. So what I'm going to do is I'm going to go to my create event, and I'm going to create a new variable, and I'm going to call it walk ACC for walk acceleration, and I'm going to have that equal like 0.2. And then in my step event, where I am calculating my horizontal movement, I'm going to delete this. And I'm going to say if move does not equal 0, which means that we are going to be moving in one direction or the other. And now I'm going to ask if move equals 1. So are we moving in the positive direction towards the right? And then the first thing I'm going to do is I'm going to ask if HSP is less than 0, which means are we moving to the left currently? We want to be moving to the right, but are we currently moving to the left? And if we are currently moving to the left, we want to stop that movement. So if HSP is less than 0, we're going to set HSP to 0. And then next we're going to ask if HSP plus our walk acceleration is less than our walk speed. Which means if we add our walk acceleration rate to our horizontal speed, is it going to still be less than our walk speed? And if that is true, we want to add our walk acceleration to our horizontal speed. But if that is not true, so if when we add horizontal speed to walk acceleration, is it going to equal or be greater than walk speed? And depending on what you set your walk acceleration to be, it is absolutely possible that it could end up being higher than your walk speed. And if that is the case, you just want to hard code your HSP to equal your walk speed. And that's all we gotta do for accelerating to the right. And now I'm going to say else, because up here we are making sure that move does not equal 0. And then here we are asking if it is 1. And move can only ever be one of 3 values. It can either be -1, 0, or 1. And we know from this that it is not going to be 0. And here we're asking if it is 1. So when we say else, the only other value it could possibly be is -1, which is going to be moving to the left. And I'm essentially just going to be copying all of this. But I'm going to have to change a couple things. So is HSP greater than 0? If that is the case, we want to no longer be moving to the right because we are going to stop dead and we're going to start accelerating to the left. And does HSP minus walk acceleration greater than walk speed times move? And that is to make sure that, because we are now accelerating in the negative direction. So our full walk speed is going to be -4. And to make sure that this does equal -4, we're going to multiply it by -1. And this else statement lets us know that move is -1. And if our walk speed, or if horizontal speed minus walk acceleration is greater than -4, so it is between 0 and -4, then we are going to minus our walk acceleration off of our walk speed, or our HSP. And then if, again, same thing as here, we're going to want to hard code it to make sure that we end up going our walk speed. First, I want to add multiplied by move. And then all of this is going to just make sure that we are accelerating in our respective direction. But since we are accelerating and we never actually hard code HSP to 0 if we stop moving, we can accelerate, let go of the key, and then constantly move at that rate in that direction. So we're going to need to decelerate if we no longer want to be moving. So I'm going to say else here, because if move does not equal 0, so else says, does move equal 0? And if move equals 0, we want to stop moving. So the first thing I'm going to do is I'm going to figure out what HSP is. So I'm going to say if HSP is greater than 0. And that's going to be asking, are we moving to the right? Are we moving in the positive direction to the right? And if HSP is greater than 0, we very simply just want to say HSP minus equals our walk acceleration. Okay, but we're going to want to run a check, just like we did up here, to make sure that when we minus our walk acceleration off of our horizontal speed, we're not going to be overclocking it and going into the other end and reversing our movement a little bit. So I'm going to say if HSP minus walk acceleration is greater than 0. And if that is the case, I want to subtract walk acceleration off of our horizontal speed. But if that is not the case, if HSP minus walk acceleration is less than 0 or even equal to 0, we just want to hard code it to be 0. So we know that we're going to be coming to a dead stop. And then down here, I'm not going to be using an else statement because I only want this code to be running if HSP is greater than 0 or if HSP is less than 0. I don't want to be running any of this code if HSP equals 0. So I'm going to say if HSP is less than 0. And essentially I'm just going to be grabbing this code again and punching it in there. So if HSP plus walk acceleration is less than 0, HSP plus equals walk acceleration. Else, HSP equals 0. And that right there is all that we have to do to set a very, very basic acceleration and deceleration system. So if I run the game now, as you can see, we accelerate and decelerate. Then if we swap directions mid-step, we immediately turn around and start accelerating in the opposite direction. So all of this is working beautifully. So now, to fix our issue with our glitched out sprite on our vertical collision. So we are not going to need any new variables for this. We are just going to be changing this statement here. So instead of saying while not place meeting x plus x, I'm going to say while absolute HSP is greater than 0.1. And what this does is absolute gets an absolute value. So if the value is below 0, so it's a negative value, it will convert it into a positive value. So if we are moving at a rate faster than 0.1 in any direction, we are going to want to check if we are not place meeting. Sorry, not yet. We're going to cut our horizontal speed by half. So horizontal speed times equals 0.5. And then we are going to check if we are not meeting at our new location. And if we are not, we are going to move towards it. And all this is going to do is every single frame, it is going to cut our horizontal speed in half and then figure out if we will be colliding in half the distance of our HSP. And if we are not, we are going to move towards the wall at that speed, that much. And we're going to continue that process until we perfectly meet up to the wall. And we're going to do the same thing here. So I'm just going to grab this code. And instead of while absolute HSP, I'm going to say while absolute VSP. I'm going to go VSP times equals 0.5. I'm going to get rid of this and say y plus VSP and y plus equals VSP. And that will fix the issue with our vertical collisions. We will now no longer have that point where we stop dead in the air, change our sprite, and then continue falling. We will just fall evenly towards the floor. And I'll show you. Look how much better that looks. It is just a massive improvement. That's all that I have. So I'm going to thank you very much for watching. I hope that this video complemented my previous platformer movement video, and I hope that if you use my code from my platformer movement video, I hope that this cleans up your code a little bit, cleans up your game a little bit, and makes your movement system feel much more natural. And I also hope that any issues that you were having with my previous platformer movement, just visually, aesthetically, just the way that it feels, are solved by these few things. If you have any questions about what I have done here, or if you're having any troubles implementing it yourself, please comment down below and I will absolutely do my best to try to help you. If there is anything specific that you would like me to put on my channel for a tutorial, if there's anything that you are itching to learn or anything that you are struggling with that I have not yet covered, please, again, comment that down below, and I will absolutely make a video teaching you those things. Other than that, I'm just going to say thank you very much for watching. Please like, comment, and subscribe. I hope you guys are having a great one. Peace out.